So we're given this equation and we want to rewrite it in the form of an ellipse, which is x minus h squared over something plus y minus k squared over something equals 1. That's what we're trying to do. So our first step is going to be to focus on the x and y variables. I've got 4x squared minus 8x. Let's factor out a 4. So I have 4 times x squared minus 2x first. Now we have 9y squared plus 54y, which will be 9 times y squared. 9 times 6 is 54. Plus 49 is 0. And this is going to require us to complete the square. So we're going to take 4 times x squared minus 2x plus something on this side. Then we're going to go to 9 times y squared plus 6y plus something. And then we have plus 49 equals 0, or if you like, equals negative 49. And we want to figure out what's going to go in those somethings. That's going to be our goal. So let's look at that. This is going to be a fairly extensive process. So we'll rewrite that again, or rewrite it. So we have 4 times x squared minus 2x plus 9 times y squared plus 6y plus equals negative 49, and we're going to add some stuff there too. So we'll see what we're going to have to add there. So what do I do next? How do I complete the square on x squared minus 2x? Well, let's look at it. X squared minus 2x is minus 1x and minus 1x. So x times x is x squared, minus 1 times minus 1 is minus 1x, plus 1 completes the square. And what that gives me is x minus 1 times x minus 1. Oops. Or if you like, x minus 1 squared. So I've got to add 1 to complete the square. But if I do that, what did I really add? This is what I want you to see. 4 times 1 is 4. I have negative 49 on that side. I have to add 4 to counterbalance that, to be fair. Over on this part, I have y squared plus 6y. So we're going to complete the square there. How is that going to work? Y squared 6y is plus 3y and plus 3y. So we get y times y is y squared, plus 3 plus 3, plus 3 times plus 3 is plus 9. If I do the plus 9 there, what do I get? Y plus 3 times y plus 3, or y plus 3 squared. So I add 9 here. But what if I really added? What if I really added not 9, but 9 times 9, which is 81? So this first part is 4 times x minus 1 quantity squared, as we showed. 4 times x minus 1 quantity squared, plus 9 times what? Y plus 3 quantity squared, equals negative 49 plus 4 plus 81. Negative 49 plus 4 plus 81 is 36. Well, didn't that work out nicely? Because as you know, I need the right-hand side to equal 1. So to do that, I will divide everything by 36 to get it to equal 1. Divide the first piece by 36, second piece by 36, last piece by 36. So now I have x minus 1 squared. 4 divided by 36 is the same as 1 divided by 9. X minus 1 squared over 9 plus 9 over 36 is the same as 1 over 4. y plus 3 squared over 4 equals 1. This is now in the form I wanted. Remember, x minus h squared over something plus y minus k squared over something equals 1. The larger number is on the x direction, so I'll call that a squared. I'll call that b squared. Fine. Now, what's our center? Our center is h is 1, y is negative 3. Excuse me, k is negative 3. So the center is 1, negative 3. So let's go ahead and put that in on Desmos. If I can do that. So we have the point 1, negative 3 is the center. So there it is. Now what about our span in x and our span in y? We know 9 is 3 squared. We know 4 is 2 squared. So let's rewrite that again. X minus 1 squared over 3 squared plus y plus 3 squared over 2 squared equals 1. So the term I like to use, span in x is 3. So I go 3 either direction in x. So let's look at that. What would that be? So here's my center. If I go 3, if I add 3, where does that put me? It puts me at 4, negative 3. If I subtract 3, where does that put me? That puts me at negative 2, negative 3. So that gives me my vertices. That will be the major axis. So vertices at 4, negative 3, negative 2, negative 3. So we have that, which is good. So let's see that. Right, 1, negative 3 is our center. 1 plus 3, negative 3 takes me over to 4, negative 3. 1 minus 3, negative 3 takes me to negative 2, negative 3 to give me those 2 points. Again, on the major axis. How do I know it's the major axis? Because there's a larger number here in x than in y. Now the span in y is 2. We see that? Span in y is 2. So I've got to go up 2 and I've got to go down 2. So let's just go ahead and get our vital information. Here we have our equation, which is x minus 1 squared over 3 squared plus y plus 3 squared over 2 squared equals 1. Our center we established was 1, negative 3. Our span in x we said was 3, which gave us vertices at 4, negative 3, negative 2, negative 3. What about our span in y? Our span in y, as we said, was 2. So we go up 2 and down 2 from the center. Our center was 1, negative 3, is what it should have been. Our center was 1, negative 3. So I go up 2 and I go down 2 from 1, negative 3. Let's look at that. So again, here is our center point. If we go up 2 in the y direction, it puts me there. If I go down 2, it puts me there. So those are the endpoints on the minor axis. So what are they? 1, negative 1. Endpoints on minor axis. Would be 1, negative 1 and 1, negative 5. So we have our vertices, we have our endpoints on the minor axis. How about the length of the major and length of the minor? Well, again, it's going 3 in each direction, so the length of the major has got to be 6. The length of the minor, it's going 2 in either direction. It's got to be 4. And again, we can look at our picture to see that. Length of the major, 1, 2, 3, 4, 5, 6. Length of the minor, 1, 2, 3, 4. Now, I would like to get the foci. So it'll be on the major axis. Remember, the focus always exists on the major axis. C is the distance from the center. We're going to go each direction, one positive, one negative. So what's our equation there? For an ellipse, c squared is a squared minus b squared. Well, our a squared is 3 squared. That's our larger of the two. Our b squared is 2 squared, so c squared is 9 minus 4, so c squared is 5. So c is plus or minus the square root of 5. So we are going in the direction of the major axis, in the direction of x. Our center is 1, negative 3. So we want to get our foci, we've got to go root 5 in the x direction from 1, negative 3. What would that be? 1 plus root 5, comma negative 3, and 1 minus root 5, comma negative 3. So let's take a look at that on Desmos. So 1 plus square root 5, comma minus 3. And 1 minus square root of 5. Minus 3. So these are the foci, focuses. These things were the vertices, right? And then these two guys were the endpoints of the minor axis. So if I put all this together, I should get my graph. Remember what the equation was? X minus 1 squared over 3 squared, or 9, plus y plus 3 squared over 2 squared, or 4 equals 1. Let's go ahead and do that on Desmos and see if that is correct. Does it go through the vertices and the endpoints of the minor axis? X minus 1 squared over 9 plus y plus 3 squared over 4 equals 1. What do I get? I get a nice looking graph. It certainly seems to go through the vertices and the endpoints of the minor axis. And again, remember your foci, a squared minus b squared, 3 squared, 9, minus 2 squared, 4, 9 minus 4 is 5. That's root 5 over 1 plus root 5, comma negative 3, 1 minus root 5, comma negative 3.